Hey, Elisa. You win. You're the first in class today. I'm running around like a chicken with my head cut off, as usual. Oh, my blood pressure's up. Hair looks horrible. Hey, Sheldon. Good afternoon. Bye, Sheldon. You think your Jeep just runs out of gas? Hey guys, here is the link to our whiteboard today. Hey Sheldon. This is our last session on ACT Help. I'm going to share my screen. If you've not been able to come to the other sessions, I have been recording. So today I am going to start off where I left off and work to the end of the last question. There are 60 total questions. I don't remember exactly where I got yesterday, but we were close to 40. That was our goal, to try to get to number 40. I think that's where we got. And so today we're going to be working 51 through 60. Hey, Luke. All right, it is 1:59. We'll wait till 2:01, and then I'm going to hit the ground running. I'm already recording, so we should be good to go. I'm going to start with number 37. That was the problem that I skipped, and I'm going to go back. Grace stayed with me at the end, and she goes, oh, this is how you do it. And so I had a mental block about number 37, but we'll go back and look at that one. That is one that I did skip yesterday. So I don't know if y'all's brain ever does that. It's like it's supposed to know something, and then you did it before and you've done it, worked the problem, and then I don't know. I am my own worst enemy. Sometimes I can just confuse myself. I make things so much harder than they actually are. I am an over-analyzer. Just like simple daily things, I'll find myself, and people will be doing them a totally different way. It's much more productive, but I'm always doing it the long way. I don't know. Hey, Jemiah. Hey, Jada. Hey, Alexa. Hey, Kenzie. We're going to wait till 2:01. Hey, Maddie. And then we're going to hit the ground going. I did set this up as a part 1, part 2. The part 1 had the first 30 problems. The part 2 had the last 30 problems. So this is where we were. We got started on part 2 towards the end of yesterday's session. So, hey, guys. Howdy, everybody. Hey, Janeria. Hey, Maddie. I'll make sure my phone's off. And it's 2:01. So put my pencil down. I can't write with that. Okay. I do want to go to number 37. I skipped this one yesterday because I had a brain block. I actually looked at this one the night before, and I worked it last year, and then for some reason, I don't know, it just didn't make any sense to me. Sometimes that happens. You can still miss 2 problems and get a perfect score on the ACT on the math section. So this would have been one of the ones I missed because I just couldn't figure it out. Grace stayed at the end of class yesterday, and she goes, oh, it's 35. She made it look so easy. So thank you to Grace All right, so I'm going to go back to 37. We got all the way to 40, okay? But I skipped 37 because I didn't know how to explain it, and so now I do. Thanks to Grace. It says, for how many volunteers did the SAM 77 test give an incorrect result? So just to take you back to yesterday, there is something called a Gene YQ77, and there's a test according to this problem called the YQ. It's $2,000 for a test, but it's 100% accurate. And then Sam came along. He found a cheaper test for $50. He named that test the SAM 77. It's not always accurate, but it's accurate sometimes. And they're asking us how many volunteers it took. For how many volunteers did the SAM 77 test give an inaccurate result? So we did not answer number 37 yesterday. I said if anybody knew how to do it, they could email me how to do it, and I would share in the next class. So if you're just joining us, the link to the deck that we're using is in the chat. There it is again. And on 37, if we go and look at the positive YQ test, so the YQ test found that 590 and 25 were positive, but the SAM test found that 25 were negative, so those 25 are incorrect. And then for the negative YQ test, they found that 10 were negative and 375 were negative, but the SAM 77 test found that 10 were positive. So that means 10 plus 25 were not accurate. It's really not that many that were inaccurate versus a $50 test and a $2,000 test. So I don't know. I might try the $50 test first. I don't know, $2,000. That is a lot of money for a test. Okay. So if you're just jumping in with us, this is the last session of our ACT help session. We're on number 41 on the practice test. If you did not get a practice test or any information, I sent out 2 emails over the last 2 or 3 weeks. You can reach out to me by email if you want to see the practice test. It includes all the subtests on the ACT, not just the math. But I am going to move on to go ahead and start with number 41. Any quick questions before I begin? I don't have any time to waste, so I'll ask for questions right now, and then I'm going to move the buggy. You can email me, Janiyah, and I'll send you a document, and it has 4 practice tests, 1 for each section of the ACT, and then there are answers at the end. So it's just a PDF. It's a real ACT test that ACT put out for people to use to practice. So if you email me, I'll send you the test. Does that make sense? Oh, absolutely. Okay. For right now, I would just get on the whiteboard link, and then you'll have the questions, and you can save that deck at the end. And then you'll have 31 through 60 worked out. If you want the other whiteboard link, you can go to the Bitmoji Classroom and content, or you can email me for it, either one. All right, good deal. All right, number 41. It says the equation 24x. Let me remind y'all of this. I know that you know this, but the problems get harder as you go. So we're on number 41. The first 20 out of the 60 questions on the math, the first 20 are the easiest, and they progress and get harder. Most of this you have been taught up through your Algebra 2 class. There are a few things that we've not covered in Algebra 2, and 4% of the math on the ACT comes from pre-calculus. So there's a chance that there's a tiny bit of pre-calculus that you haven't seen yet. So that's always a really good reason to go through a practice test, so you can at least try to figure out some things you've not been taught yet. So hopefully those things that you've not been taught yet are minimal, and we can discuss those as we go through the 60 problems. All right, number 41. The equation 24x squared plus 2x equals 15 has 2 solutions. What is the greatest of the 2 solutions? So this is actually something that we did before Christmas. So I'm going to take my equation and I'm going to solve it for 0. So I'm going to bring the positive 15 over to the left-hand side. And I'm going to factor. I end up with a trinomial 24x squared plus 2x minus 15. It's a trinomial. We know trinomials most of the time factor into two binomials. I was hoping there was a greatest common factor that I could divide into 24, 2, and 15 because those are pretty big numbers, but there's not. If there were, go ahead and divide out the GCF. That's going to make your factoring a little bit easier. 15 is negative, so that's going to tell me that my signs are different. And then 24, it could be 1x and 24x, 2x and 12x, 3x and 8x, 4x and 6x, lots of possibilities. You're going to just have to go through those possibilities. I ended up using 4x and 6x. And then these two numbers have to multiply to be 15. I ended up using a 5 and a, nope, I reverse those. My 3 is going to come first. And my 5 is going to come second. And then to make these the correct factors, I also had to change my signs. So it's going to be a positive 5 and a negative 3. So the factoring on this one is pretty difficult. So you'll have to go through, when we do this, the 4x times the 6x, when we factor, the first terms have to multiply to be 24x squared. The last terms have to multiply to be negative 15. And then remember, we have to check the inside product, the outside product, and those two terms have to add up or combine to be your middle term, to be that 2x. So this is a pretty hard trinomial to factor. So you've got to make sure that you get the trinomial factored correctly. And then does anybody know what my next steps are going to be? What am I going to do to each one of these factors? I'm solving. Anybody know what I'm going to do to each one of those factors? Set them equal to 0. You got it, Janeria. So we're going to take 4x minus 3. If I can write, we're going to set that equal to 0. We're going to take 6x plus 5. We're going to set that equal to 0. We're going to add 3 to both sides. We're going to divide by 4. And one of my solutions is going to be 3/4. Over here, we're going to subtract 5 from both sides. We're going to divide by positive 6. And my other solution is negative 5/6. And it is specifically asking for the greater of the two. So a positive number is always going to be greater than the negative. So I want to go with the positive. And on this one, I'm going to answer A. So this is solving a quadratic equation, meaning it's got that x squared in it. A lot of times when you're solving, factoring is going to be the way to go there. You could use the quadratic formula. You could graph. Okay, you could put this in your TI-84. You would have to solve it for y. So you would have to put it in, this would have to go in for your y equals. And then you could trace maybe to find out. Remember, these solutions are also going to be where the graph crosses the x-axis. So I'm just kind of trying to give you some other options, as in other options as in on how to work the problem. Okay, so I am going to, hold on just a second. All right, I'm getting a private message. I've got to really get through number 60, so I'm not ignoring y'all. I'll try to answer questions at the end, and I'm going to try to watch what's in the room chat. So if you have a question, put it in the room chat. If you have a private message, I'll try to get to that once I get to number 60, because that's just going to kind of slow me down. And our goal here is to try to work through all 60. And then if you have a question, you can let me know. So again, we're reviewing for the ACT. This is for juniors this year. If you're a senior, you can still take the ACT. You can take that on your own if you're trying to get in college or get tuition. Okay, we're just reviewing for the ACT right now. So this is kind of a focus for 11th graders. It is optional. We're on number 42. Which of the following expression is equal to sine of 60 times cosine of 30 plus cosine of 60 times sine of 30? Okay. What I did is kind of unorthodox, but this is a pre-cal problem, and you've not learned these rules. Okay. So I went ahead and snipped the rules here and I pasted them in. But just to be super honest with you, you're not probably going to memorize those rules by the time you take your ACT next week. So I'm going to show you how to do this without knowing the rules. So I would take my calculator and I would actually type this whole line in to my calculator. So I'm going to use remember you can take your TI-84, and then if you have just a calculator that you just love because you use it all the time and it's easy to use, you can take multiple calculators. You can only have one on your desk at a time. But I'm going to type this whole entire line in. You might want to do the same. I'm also noticing that my calculator is set in radians, and it's 60 degrees, 30 degrees. So I know it needs to be in degrees. So I need to change that. That's going to give me crazy answers. All right, now it's in degrees. So I'm going to do parentheses, sine 60. I'm going to type it in just like it looks. Times parentheses, cosine 30. Parentheses around all that, plus parentheses, cosine 60. Parentheses, sine 30. Let's see if I type this in right. Okay. I am getting 1, and that's not right. Okay, so let me just type this part in my calculator because apparently I can't type anything in my calculator today. So I want to do sine of 60 times cosine of 30. And that's giving me 0. Still not giving me the right thing. That's giving me 0.75. I wonder if I did it in radians when I worked it out. I think I probably did. Okay, maybe I did do it right. Cosine 60 times sine 30. Yeah, I guess I actually put it in right. So that's 0.25. And then when I add 0.75 with 0.25, that gives me 1. So then what I did is I just went down and put all these in my calculator until I got something that equals 1. That's a little bit long. That's actually like you not knowing the rule, but I really don't think this is something that you can learn this quick just because it comes from pre-cal. So totally up to you. So I went ahead and just changed 60 minus 30 to 30 and just typed in cosine of 30. That's not going to give me 1, so I'm just going to mark that out. That's going to give me 0.866. And then cosine of 60 plus 30, I'm going to do cosine of 90. That's going to give me 0, so I'm going to X that out. I'm looking for a 1. Sine of 60 minus 30 would be sine of 30. That's going to give me 0.5, so it's not going to be that one. The next one's going to be sine of 60 plus 30, which is 90. And that's going to give me a 1 right there. So I'm going to choose J. If I did K, I would not get the answer there. I think when I did it on my paper, my calculator was in radians, and so I didn't get a 1, and I thought that I made a mistake in my calculator. All right, questions about 41 or 42. So I think this one actually, this is the rule that it follows is this first one. And you can kind of see how that matches up. Honestly, I've taught pre-cal for years, and my students didn't do a very good job of memorizing these, even when we studied this unit for like 2 weeks. So I would say use your calculator for this one. All right, moving on. Number 43 says, what is the area in square units of a circle that has a circumference of 12 pi? So you do need to know the formula for circumference. There's actually two. We can use pi times the diameter, but because we're needing to know the area, the formula for area is pi r squared. So they're asking us ultimately for area. So I need the circumference formula that has the radius. You could go ahead and do this one, and then remember that the radius is half the diameter. I'm going to use the formula for circumference 2 pi r. And then I know the circumference is 12 pi. Yep, Kenzie, you got it. I know my circumference is 12 pi. So then if I solve for r, I divide both sides by 2 pi. And that tells me that my radius is 6. And then I take my radius, I go in to find the area, and the area is going to be pi times radius 6 squared. And they like the 36 written in front. 6 squared is 36. They like that 36 written in front. And so I want to choose in front of pi. I'm going to choose D for that one. So what if you don't know the circumference formula? You're kind of got to be up the creek without a paddle on that one. So that's definitely something that you need to know. So make some notes of some formulas. I also emailed y'all a formula sheet, and on the first day of the help sessions, I sent that out. If you don't know where it is or you never got it, just email me. And this sheet just tells you all the formulas that you need to know. It doesn't mean that the ACT is going to give it to you, but sometimes they give you a formula and a problem. Sometimes they don't. All right, 44. I'm going to put a big frowny face on 44. This is a mixture problem, and me and mixture problems just never got along. This is something that you actually supposedly were taught in Algebra 1. My chemistry teacher also did some of these, but they just never completely made sense to my brain. So this says a barrel contains 25 liters. That's important. That's our total number of liters of liquid of a solvent mixture that is 40% solvent, 60% water. So those two percentages are going to play into this problem. They're going to be important. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel so that the new mixture is 50% solvent and 50% water. How many liters of pure solvent should Lee add to create this new mixture? So what I did is I did 25 liters, and then I multiplied that by the decimal for 40%, and that gave me 10. And then I did 25 liters again, and I multiplied by the decimal for 60%, and that gave me 15. So what we want is we want a 50%, 50% solution. So we want this solution to be just as powerful as this solution. So right now the solution on the top, there's only 40% of that solution in our mixture and 60% of the other. So if I want these to be the same, then in my mind, I kind of see it like this. What do I need to add to the 10? Because 10 is smaller than 15. What do I need to add to the 10 that's going to give me the same amount of this mixture as I already have in this one? So I always go with the smaller one and say, what can I add to 10? That's going to make it 15. And that's going to be 5. And that's actually the answer. There's probably, again, multiple ways to do all of these problems. That's just kind of how my brain thinks through it. And y'all have heard me say this before. I'm not a super smart problem. I'm not a super smart person. I've always had to work really hard and study. And I've also never been a really good test taker. So I just kind of try to explain what I'm thinking in my head, and maybe it'll help you. All right, moving on to 45 and 46. 45. 45 has Algebra 2 written all over it. It is something that we did before Christmas when we were adding and subtracting ugly polynomial rational expressions that did not have common denominators. So that's what's going on here. I'm trying to add I'm trying to add these two fractions, and one fraction has a denominator of x plus y, and the other one has a denominator of x minus y. They're super close to being the same denominator, but they are not. So does anybody remember a little trick that I taught y'all? If you have two denominators and they're different and you're trying to find the common denominator, what's probably the quickest thing that you can do to find a common denominator? Anybody remember? I also talked about this problem as like going shopping for a common denominator. And I pretended that I had a little shopping cart, and I said, we need one of everything. No memory out there. Multiply them together. Jordan got it. So a quick way to find a common denominator, it might not be the least common denominator, but you know, what the heck, as long as it's a common denominator. So I'm going to actually take those two and I'm going to multiply them together, and I'm going to create my new denominators. So anytime you're adding or subtracting, you have to have the same denominator. To find a common denominator when you don't have one, you can always just multiply them together. So when we're going from this old denominator to this new one, we already have an x plus y, but we need an x minus y. So we have to multiply the top and the bottom by x minus y. This is a very detailed algebra 2 problem. I mean, it's just got algebra 2 written all over it. When I go from this denominator to this new denominator, I have to multiply by x plus y. So I have to multiply the top by x plus y. Then I'm going to simplify the numerators. So I'll distribute. That's going to give me x squared plus, not plus, but minus. My stomach's growling. I don't think I ate all my lunch today. Today's been one of those days. And then that'll be in my numerator. And then I'll have the x plus y, x minus y in the denominator. I'll have a plus here, which is good. Plus is always better than a minus. And then y times x, I'll reverse those and write them in alphabetical order. And then y times y is y squared. Then I can add my two numerators. As long as I'm adding, none of my signs are going to change. This minus xy and this positive xy are opposite, so they'll cancel out. And I'm going to end up with x squared plus y squared on the top, and then x plus y times x minus y on the bottom. And this is where you're like going, please, 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 please let this be one of the answers. And it is. It's E. My husband was making fun of me last night because I couldn't figure out how to do number 37, and he was telling my son, who's the engineer, that yeah, your mom's she's been working on the ACT for 32 years. Yeah, she's been studying for the ACT for 32 years. So yeah. Anyway, I have been doing stuff like that for a long time. All right, 46. Mary James and Carlos sold 1/4 page advertisements for a school yearbook. Mary sold twice as many as Carlos did, and James sold 3 times as many as Mary did. What fraction of these advertisements did Carlos sell? And this is when we say, when are we ever going to use this? Why am I doing this? My life is miserable. But then we move on and we start thinking about, so first of all, this problem has nothing to do with the size of the advertisement. That's a good thing. Okay. But it does have to do with all these comparisons. It's telling us about Mary, how many Mary sold. It's telling us about Carlos, how many Carlos sold. And it's telling us about James. So this is just how my brain processes. So it says Mary sold twice as many as Carlos. So I said, okay, X is Carlos, 2X is Mary. Sometimes that works. Sometimes you can just like get it right the first time. Sometimes you don't. You have to erase and you have to start over. And then it says James sold 3 times as many as Mary. So what I did is I wrote down James, and then I wrote down 3 times Mary, which I set up as 2X. So James is going to end up being 6X. And then it says, what fraction of these advertisements did Carlos sell? So fraction means what part. So we've got to do part over the whole. So who are we doing again? Carlos. So Carlos is going to be X. His part was X over everybody's added together. So 1x plus 2x plus 6x is going to give me 9x. So it wanted to know what fraction of the advertisements did Carlos sell. He sold X out of 9x. The X's are going to cancel. And so Carlos didn't do a very good job. He only sold 1/9 of the advertisements. If he was getting paid on commission, he wouldn't have gotten paid very much. Okay. Again, there's probably multiple ways to do that. You could have maybe taken the answers and figured it out. Me, I just set up some expressions to represent because they were comparing everybody's sales. Any questions about 45 or 46? All right, moving right along. Number 47, in a window display at a flower shop, there are 3 pots for 1 plant each. To fill these 3 spots, I said pot, excuse me, 3 spots for 1 plant each. To fill these 3 spots, Emily has 6 plants to select from, each of a different type. Selecting from the 6 plants, Emily can make how many possible display arrangements with 1 plant in each spot? Okay, so again, this is how my brain works. There are 3 spots. So I see 3 blanks. So the 3 spots that we can put the plants. There are 6 plants. So when we go to put a plant in this first spot, I have the choice of 6 plants. Okay. When I go to put the pots in the second, put a pot in the second spot, there are not 6 plants anymore. How many would there be? Five, because 1 pot is sitting in that first spot. And then when I go to put a pot in the third spot, because I already put 1 in the first spot and I already put 1 in the second spot, then I only have 4 plants left. And this is what we call a combination. This is something that you probably did later in the year in Algebra 1. Honestly, a lot of people forget how to do these. And then you just multiply them together. So 6 times 5 is 30. 30 times 4 is 120. So there are 120 different arrangements. Another word for arrangements is combinations. Y'all remember doing those problems where they said you go into a sandwich shop and there's 4 different kinds of bread, 3 different types of meat, 2 different types of cheeses. What's all the different combinations of sandwiches that you can make? And you just multiply all those choices together. That's the same type of problem. But you've got to remember it's going to be 6 and then 5 and then 4 because you're putting, you're leaving a pot in the first spot and then you're leaving another pot and so forth. All right, 48 and 50, 48, 49, and 50. This is one of these directions, not multi-directions, one set of directions for multiple problems. I always forget this and get to the very last problem and think I don't have enough information. So I would just make a mental note, maybe jot it down on my paper because you'll have scratch paper, just something like 48 through 50. So it will remind you that if you get to number 50 or number 49 and you're wondering some information, what is it? Then you have to go back to this one little set of directions. So it says the quadrant function, the quadratic function f and triangle MPQ are graphed in the quadrant XY coordinate plane below. Points M 2A, 5B. So if you'll notice, to get to point M, I've got to go right 2A and up 5B. So it's a little bit weird the way they label the axis, but again, they're doing that just to make the problem a little bit harder. It says point N, which is right up here, has the ordered pair 4A, comma 9b. So we would go to the right 4a, and then we would go up to 9b. And then it's telling you everybody else's order pair. Okay. It says that the point Q, which is here, is not on F. So F is the parabola. Okay. So it's just saying that point Q, which is located right here at 4a, comma 0, it's not on F. And then they've got an arrow pointing to F, meaning the parabola. So the question is 48. In terms of A and B, what is the area in square coordinate units of the triangle MPQ? So there's only one triangle. That's good. Here's MPQ. I would use the formula for the area of a triangle, 1/2 base times the height. And then hopefully I'm going to be able to count the base and the height from the graph. I think that's why they put it on a graph. So I'm just going to kind of erase this to make it less complicated. So I would say this is my height and this is my base. So my base is, if this is 2a, I'm going from 2a all the way to 6a, looking at my x-axis here. So my base would be 4a. My height is going from 0 to 5b. So from here to here is 5b, so my height would be 5b. You can't multiply the a times the b, so you'll just squish the a and the b together, but you can do 1/2 of 4 times 5, and that's 1/2 of 20, and so your area would be 10ab, and we would choose G. So to me, just labeling the axis with A's, the x-axis with A's and the y-axis with B's, and then you're going to have to know this formula. This will be just a formula that you're just supposed to like pull out of your brain. They're not going to tell it to you. So definitely make sure that you know the area formula for a triangle. All right, we have the same directions for number 49 and number 50. So let's take a look at number 49. It says the point M will remain fixed and point Q will move to the right along the x-axis. So M will stay. It's not moving. Q will move to the right along the x-axis. As Q continues to move to the right, which of the following statements describes what will happen to the slope of MQ? So right now, the slope of MQ, if I count rise over run, 1, 2, 3, 4, 5 over 2. Right now, the slope of the line MQ is negative 1, 2, 3, 4, 5 over 2. Negative because that segment is going downhill. So I think that's just a delivery, I hope. The way my brain works is, okay, right now where Q is, the slope of MQ is negative 5/2. So what's going to happen if I move Q over? So if I move Q over here, then my slope is still going to be 1, 2, 3, 4, 5, but then it's going to be over 1, 2, 3. So then it's going to go to negative 5/3. And then if I move it over again, it's moving to the right because that's what the direction said. Then it's going to be negative 5/4. And then if I move it over again, it's going to be negative 5/5 and so forth. Okay, it's going to stay negative, except this bottom number is going to continue to increase and the top number is going to stay 5. So let's take a look at our answers. A says the slope will decrease and eventually be negative. Well, the slopes are all negative. Can't be A. B says it will decrease, but it will never be negative. That's not true. C says it will stay the same. That's not true. D says it will increase, but never be positive. So I don't know about you, but fractions don't always gel with me. So I went in and looked at the decimals here. So I'm rounding a little bit. This is negative 1.25. So compare those decimals. Do y'all see that they are getting larger? They're getting closer to 0, even though they're all negative. So the answer to this one's going to be D. we'll go ahead and check out E just to make sure that we didn't make a mistake. E says the slope will increase and eventually be positive. The slope's not ever going to be positive because M is fixed. So no matter where Q ends up being, my line is still going to go downhill. Okay. All right, number 50. Still going with the same directions for 48 through 50. 50 says one of the values is equal to f of 5a. Which one? One of the values is equal to f of 5a. So 5a is my x. So if I go over to 5a and I travel up to my function, and I know I'm using my function this time. Whew, it's a squiggly line because it says f. And then I go over and match what the y value would be. So that's going to be equal to 8b. So they're giving you the x value. You got to go up to your function and find the y value. So for number 50, I said k. Any questions about 48, 49, or 50? Those all went with the same directions. All right, 51. 12 jurors are needed for an upcoming trial. The diagram below illustrates a part of the process of jury selection. I've always wanted to be on a jury, but it hasn't happened yet. The 12 jurors will be selected from a jury pool of about 60 people. The court records show a trend that only 40% of the people who are summoned for jury duty actually appear. And that of the people who appear, only 1/3 are excused based on the questions that the attorneys ask them. They get told to go home. If this same trend continues, how many people should be summoned to have as close to a possible of 60 people? So I kind of worked backward on this one. I started with my answers. So do y'all see 45 is not even that's not even a possibility. We don't want to ask 45 people to come in if we need 60 to stay. Does that make sense? And 90 seemed too small also. So I kind of just eliminated A and B. And then I went to 150. And I started with, what was the first percentage that they gave me? 40%. And I took 40% of 150. So I multiplied it by 0.40. And I got 60. And then it said 1/3 were excused. So if I took 60 and I divided it, or multiplied it by 1/3, I would get 20. So 20 people would be, well, I don't even need to do that, right? Because we got to have 60. So it's not 150. Does that make sense? I could have stopped there. So then I went to 225 and I did the same process. So I took 225. I did 40%. I got 90. I did 1/3 of 90 and I got 30. I subtracted the 30 because those are the ones that are excused. And then I got the magic number 60. And so I chose D. Again, you could have thought through this a different way. Every brain is different. I'm just sharing with y'all how my brain thinks. All right, 52. What is the 275th digit after the decimal point in the repeating decimal? So this decimal is 0.6295, 6295, 6295, 6295, and so forth. So what I did is I counted 4. So there's 4 numbers that repeat. And then if I want to know the 275th digit, then I divided 4 into 275. 4 goes into 27 6 times. 24, 35. 4 goes into 35. 8, 9, 8 times. 8 times 4 is 32. And so what I'm doing is I'm looking for what's left. So 3 is left. So that means that I'm going to go 3 digits in and the 9 would be the digit that's in the 275th spot. So the remainder is going to tell you which digit to go to. So if the remainder is 1, you would answer 6. If the remainder is 2, you would answer 2. If the remainder is 3, you answer 9. If the remainder is 4, you answer 5. If the remainder is 0, that's a good question. 1, 2, 3, 4. If the remainder is 0, I've asked myself a confusing question. I've confused myself. Maybe they won't ask you. So if it were 3, maybe it would be 0. Maybe it would be this 0. I think so. Okay. Whew. All right, 53. Given the function x squared minus 4 and g of x, x plus 3, what are the values of x for which f of g of x equals 0? So this is a combination function problem. This is something that we covered this semester in Algebra 2. When we added functions, we subtracted functions, we multiplied functions, and we divided functions, but we actually did not do what we call combination functions. So this could be considered a pre-cal problem. I can easily, I think, explain it to you. So what they're saying is if you find g of x, so let's just take the answer. So if I take -5 and I plug it into the x and my g of x, and I add 3 to that, that gives me -2. And then I plug the -2 into this equation because it says after you do g of x, you've got to take that answer and plug it into your f of x. So we're going to take that -2, we'll plug it in here. -2 squared is +4, and 4 minus 4 gives you 0. So -5 would work. Okay. So if you miss that, so we're going to do -5 plus 3 because that's g of -5. So g of -5 would give me -2. Then I take -2 and I plug that into my f of x function. And that's going to give me 0. And that's what it's wanting to know. Which one of these sets of solutions are going to give you 0? So the -5 works. It's the only one that's -5. So A is probably the answer, but I'm going to go ahead and show you how to do the -1. So we're going to start with g of -1. So we're going to put -1 into that x. So g of -1 is going to give me 2. So then I'm going to take 2 and I'm going to plug it into my f of x function. So I'm going to do f of +2. That's going to give me +2 squared minus 4, which is going to give me 4 minus 4, which is going to give me 0. So both of these are going to give me 0. When I plug into g, get that answer, plug that into f, that's going to give me a final outcome of 0. All right, 54. Given that p is a positive number, n is a negative number, and the absolute value of p is greater than the absolute value of n, which of the following expressions is the greatest value? Okay, this is the only way I know how to do these. It says that p must be positive and n must be negative. So I actually just made up two numbers. I made sure my p was positive and my n was negative. You could pick any numbers under the sun as long as p is positive and n is negative. And then I just plugged them in, okay? I just plugged them in and I did p minus n. So that's 5 minus -2. That's going to be 7 over p, which is 5. And I'm going to take the absolute value of that, and that's going to give me 7/5. I did the same thing over and over again. For g, I'm going to do p minus n. That's going to be 7 again over n. That's going to be -2. That's going to be absolute value of -7/2, which is +7/2. I'm going to do p plus n. P plus n is going to give me 3 over p minus n is going to give me 7. I'm going to do the absolute value of +3/7, and I'm going to get 3/7. P plus n again, which is 3 over p, which is 5. Absolute value of 3/5 is going to give me 3/5. P plus n is 3, and you might start to see a pattern and you might stop at this point. over n, which is -2. Absolute value of -3/2 is +3/2. And they want to know which one is the largest. So for this one, I got G. This would be 1 2/5. If we did the mixed number, this is 3 1/2. And those are all smaller. Some people can reason those out without picking numbers. That's too complicated for my brain. If you can reason it out without picking numbers, that's going to save you time. Do whatever takes you the least amount of time. Questions about 53 or 54? I got 13 minutes. All right. If y'all want me to go back to something, I will. All right, 55, imaginary numbers. We studied about these before Christmas in Algebra 2. You may have forgotten, but we know that the imaginary variable I stands for the square root of -1. And we also know, they didn't tell us this, but we also know that I squared is equal to -1. So you kind of got to know all that. So I'm going to rewrite this a little bit bigger, and I'm going to show you what I did. I attempted to simplify the top and the bottom, and I will explain how I did that. So there's not anything I can do with this I, okay, but I can, and this is supposed to be plus, 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 plus. There's not anything I can do with this I, but I can change this I to a -1. So that's going to give me I plus -1. I to the third has an exponent that's 2 or more. So that means that number will simplify. So I'm going to break it down into I squared times I. And then that I squared is going to turn into a -1. And then I'll show you just a second what the top is going to simplify to be. My I cubed, I'm going to factor it just like I did the I cubed in the top. I'm going to break it down into I squared times I. That I squared is going to turn into a -1. My I fourth, I can actually break it down into I squared times I squared. So that's going to be -1 times -1. And then my I to the fifth, I can break it down into I squared times I. That's going to be -1 times -1 times I. So what do we have up here? We have I plus -1. Let me try to go up here to have a little bit of room. We have I plus -1 plus -1 times I. So that's going to be a -I. And then on the bottom, I have -1 times I, which is -I. I have a -1 times a -1, so that's going to be a plus a +1. And then I have -1 times -1 times positive I, which is going to be positive I. On the top, the plus I and the minus I will cancel out. I'm left with a -1 on the top. On the bottom, the minus I and the plus I will cancel out. I'm left with a +1 on the bottom, and then -1 divided by +1 simplifies to be -1. I probably think this might be one of the hardest ones in my mind that we've done so far out of the 60. I don't know what you think, but there's a whole lot of Algebra 2 in there, but the answer to this one is B. So basically what I did is if I could rewrite anything as an I squared, I did, and then I turned that into -1. And I just kind of worked it out from there. It was really based on I squared being -1. All right, number 56. In the following graphs and the standard form, standard coordinate plane, the solution set to the system of the inequalities below is shown shaded. Which one? So I have a linear inequality. My first inequality is linear. My second one is quadratic. So I started with the linear. I started with a line, and I solved it for y. So I could try to match the line. The line's always going to be easier than the circle. Oh, my bad. This isn't a quadratic. It's a circle. I didn't see the y squared. So I'm going to have 2y is less than or equal to -x plus 6. I'm going to divide everything by 2. I'm trying to find the slope and the y-intercept. So I'm going to get y is less than or equal to -1/2 is my slope. +3 is my y-intercept. I do have an equal to, so that means my line is solid. So I know the answer is not G because it has a dash line. So I can eliminate G. So I'm looking for a line that has a slope that's -1/2. I can eliminate J because this line's going uphill. And then I have to go from there. My y-intercept is +3. They've not labeled anything here. So really the only thing I can do is think about less than. Less than means I'm going to shade below. So below, F could be still a possible answer. K, I'm shading below the line, so K could be a possible answer. But on H, I'm shading above. So this is definitely less than, so it can't be H. Okay, so I narrowed it down to F and K. Now I've just got to decide about the circle. So the circle on F has a larger radius, and the circle on K has a smaller radius. So now I'm going to go to the equation of my circle, which we talked about in an earlier problem. We do have an equation for a circle in standard form. I'll remind you that it is x minus h squared plus y minus k squared equals radius squared. So what I need to do is I need to get this -3y squared over to the left-hand side. So I'm going to add it to both sides. That's going to give me 3x squared plus 3. Y squared is greater than 12. And then I notice that 3 will divide into all of these. So that's going to give me x squared plus y squared is greater than 4. So because I don't have a number with my x, like this standard form in parentheses, that means that my h is 0. So that means my center is at 0, 0, because I also don't have a number in parentheses with my y. So my k value is also 0. And then remember, the 4 is the radius squared. So you would have to take the square root of that, and that would tell me that my radius is 2. So we know that the y-intercept is 3. So we know that this value is 3. And if I pick this one, it's 3. So this circle has a radius larger than 3 because it's going beyond the 3. This one has one that's a little bit less than 3, and that's going to make K the answer. So they got inequalities. They have more than one inequality. That puts it into a category of a system. And then on top of that, they throw in the equation of a circle. So lots of stuff going on there. All right, I got 6 minutes. So guys, I'm just going to work through these last ones, and then if I need to stop, I can. All right, 57. Let A, B, C, and D be real numbers, given that A times C is 1. So I wrote that down right here. A times C has got to be equal to 1. It says that B plus C divided by D is undefined. And what that's telling me is that D has to be equal to 0 for that function to be undefined. And then it says that A times B times D has to be equal, A times B times C has to be equal to D, and D is 0. So if A times B times C has to be equal to 0, then that's telling me that B is 0. Because A times C is 1, so that means A or C, neither one can be 0. So that means B has to be 0. So according to the directions, A times C is going to be equal to 1, D has to be equal to 0, and B has to be equal to 0. So that would match up with D. The rest of those are not true. That's another one of those problems where they don't give you any numbers. They just give you all variables, and those can be pretty difficult. All right, 58, a cosine function, we studied those in Unit 1 this semester, is shown in the standard coordinate plane. One of the following equations represents the function. Which one? So they're giving us a graph, and they're asking us for the equation. So I know it's not F or G, and I know because it's got a 2 in front, And that would mean the graph would just go up to +2 and down to -2. So I know it has to be H, J, or K. The only way I'm going to figure this out is to figure out what the period is. So if I take one period of my graph, that's where it's going to go all the way down and come all the way back up. One period is pi. And then you're going to have to know the formula for the period of sine and cosine is 2 pi over b. So if my period is pi, and I set that equal to 2 pi over b, and I cross multiply, I get pi times b is equal to 2 pi. I divide by pi, and I find out that b is 2. So remember, your b is the number being multiplied times your x. So here your b is 1/3, here your b is 1/2, here b is 2. So you would choose K. You could also enter all those equations in your TI-84 and match it that way. That might just take you a little bit longer. All right, last two. We're going to do it. The figure below shows a flying kite. At a certain moment, the kite string forms an angle of elevation of 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 240 feet from A on level ground, is 45 degrees. And they've labeled all this. That's going to save you a little bit of time. It says, what is the length in feet of the string? So here's your kite. They're asking us for the string. They've labeled it. So I'm just going to put X here. And this is not a right triangle. So we can't use right triangle trig, but we can use law of sines. This is something that we studied this year in Algebra 2. And I do think I went ahead and I found this missing angle. So I added the 75 and the 45. I subtracted that from 180 and I got 60. And so I used sine of 45 over the side opposite, which is X, equals sine of 60 degrees over its opposite side, 240. I cross multiplied. I got X times the sine of 60 equals the sine of 45 times 240. And then I divided by sine of 60. And that's what X is. I would be super duper careful. This is where we over bracket. We put more parentheses than we actually need if we're going to punch all this in our calculator. And we're going to end up with X being, I got X is approximately 195.96. Let me just double check to make sure my work matches what I did before. So I chose B, because when you do 80 times the square root of 6, you're close to that number. So you would have to convert that to the decimal to get it to match. All right, last one. If a publisher charges $15 for the first copy of a book that is ordered and $12 for each additional copy, which of the following expressions represent the cost of Y the books? So the first book is 15, the second book is 12, the third book is 12, the fourth book is 12, and so on. So what I did is I just took each one and I put, you know, if I bought one book, how much would that be? 12 times 1 plus 3 would give me 15. So I kind of made a little chart here. If I bought one book, I got 15. That's what the problem says. What if I bought two books? If I bought two books, it'd be 12 times 2, which is 24, plus 3, which would be 27. So does that mean the first book was 15 and the second book was 12? Is that going to give me the 27? That's how I did this one. I just thought about, what if I bought one book? Is that 15? If I bought two books, is the additional book that I bought after the $15 book going to be 12? And so that's how I did 60. I looked at the answers and went through there. Okay, it is 3:01. I'm 1 minute over my time. If you're done and you have another class or you have somewhere to go, you are free to go, but I will hang around for a few more minutes. Does anybody need me to go back to a problem? Okay, hold on just, Jordan. I'm going to close my door because my grandkids bust up in here at about 3 o'clock. They will all come from school hold on just a second. So 60 says the first book is $15. Each additional book is $12. So what I did is one is book, Y is books. So if I put a 1 in for Y, 12 times 1 is 12. 12 plus 3 is 15. So the first book I bought, according to this expression, the cost is 15. And then I tried a 2 to see if that worked. So I did 12 times 2 is 24. 24 plus 3 is 27. So if I bought 2 books, the cost would be 27. And then I said, does that make sense? Well, the first book is supposed to be 15, and every other book after that is supposed to be 12. So 15 plus 12 is 27. I could do it again. Okay, what if I bought 3 books? Then that's going to be 12 times 3 is 36. 36 plus 3 is 39. And that would mean the first book was 15, and the second and the third book were 12. And if you add that up, you're going to get 39. The other expressions don't work. So what I would do is I would try 1 and 2. If those don't make sense with a problem, I would skip to the next expression until I found an expression that matched the problem. Where did I get the 3? This is just number of books. No, it's got glass on it. Bring it to me. Thank you for bringing it to me, though. No, I'll let you open it when I get out of class, okay? It's not what you think it is. There was a package. Where did I get 3? So I was just doing 1 book cost how much? 2 books cost how much? So according to 12 times the number of books plus 3, I was just putting in 1 for Y, 2 for Y, 3 for Y to see if it made sense with the problem that the first book was 15 and all additional books were 12. If you think about the other ones, if you do 12 times the first book plus 15, then the first book's $27. So it couldn't be this one. If you did 15 times 1 is 15 minus 3 is 12. The first book would be 12. That doesn't make sense. 15 times 1 is 15. 15 plus 3 is 18. The first book would be 18. That's not what it said. 15 times 1 is 15 plus 12 is 27. You say, does that make sense? Kind of looking at the other answers. You could start with 1 because we know that the first book costs 15. That's how I did it. And by the time you get to 60, your time's probably going to be up, and 60 may be even a problem that you even have to guess on. But you make sure that you don't leave anything blank. All right, anybody else want me to go back and slowly explain something? Just a second, I'm answering a private message. Okay, I'm back to my group chat. 56, Isabella. Thank you so much. I'm going back. Hold on. Major multitasking here. Okay. So I have a whole lot going on here. So let me do some erasing and I'll kind of back up. So this is a system of inequalities. Inequalities because I have less than and greater thans. And the first inequality is a line because it has x plus 2y and a 6. There's no x squared, so I know that it's a line. So I want to kind of try to save this part of the work. So what I did is I took the first equation. So x plus 2y is less than or equal to 6 is my first equation. Inequality, excuse me. My second one is 3x squared is greater than 12 minus 3y squared. So I started with the first one just because it was the easiest. So I took x plus 2y is less than or equal to 6. I put it in slope-intercept form, which is y equals mx plus b. So I could find the slope and the y-intercept. So I subtracted x from both sides. I divided everything by 2. And I found out that my slope, which is always the number in front of my x, is -1/2. So my line has to be going downhill. And my y-intercept is 3. This inequality is telling me that I shade below the graph because the line is less than. So I eliminated J because this line has a positive slope because it's going uphill. I eliminated G because this line is dashed. And I know because of my equal sign, my line has to be solid. And I also eliminated H because this is less than, and I know I have to shade below the graph, and in answer for H, they're shading above. So just by looking at the first inequality, I was able to eliminate 3 of the 5 answers. Okay, now both of the lines for F and K, they're both going downhill, they're both solid, and then we're both shading below the line. So it could either be F or K. I've exhausted everything I know about the first inequality, and then this is where you go to the second inequality. Since there's an x squared and a y squared, that's what's going to make the shape of a circle. I just have to get it in this standard form. And so to do that, I'm going to add 3y squared to both sides. That's how I got 3x squared plus 3y squared is greater than 12. And then I divided everything by 3.
I have to wait for my friend because we're going to have a picnic.
Awesome. Today?
Yeah.
Okay. Can you close the door until I
Where's that rainbow little thing that we had a picnic with or something?
It's in the back of Juju's car. Sorry about that. She's 6. They're just all full of energy when they get home from school. X squared plus y squared is greater than 4. According to the standard form of a circle, if there's not a number with your x, like x plus a number, x minus a number, that means your h is 0. And there's also not a number with my y, so that means my k is 0. So I know my center is at 0, 0. For my circle, that really doesn't matter because both of these circles have a center at 0. The key here is this 4. So 4 is the radius squared. So if the radius squared is 4, that means the radius has to be 2. And then I also know that the y-intercept, we found that right down here, of my line is 3. So if the y-intercept is at 3 and the radius has to be 2, then that eliminates F because this radius goes beyond the 3. So the radius is bigger than 3. And then I would have to choose K because this radius is smaller than 3. A whole lot going on that one. All right, anybody else? Nobody? Well, all right. That was a whole lot of problems to look at. Thank you so much for showing up and setting through this. And I am recording again. And so if you want to go back and look at some of these, you can. That's how I always studied, is I just looked at things over and over and over and over again. Sometimes I wrote things over and over again. Something about writing gets things into my brain. I've had people that have like recorded the answers to things like vocab. They've just recorded it and they've listened to it. Some people do better listening to things. You're welcome, Jordan. I don't know who it was that asked me, but I appreciate y'all asking. Sometimes I forget, and it helps me that I know that it's something that y'all are wanting to see. So again, it was Kenzie. I know, yeah, somebody did. But good luck. And remember, this is not the only time that you have to take it. It is required that you take it once, but especially if y'all are wanting to go to college, you can take it multiple times. You can take the ACT multiple times. And that's really what's going to get you comfortable with the timing, is to take it more than once. We definitely want you to do a good job on this one, but know that you can take it again. It just won't be free. You'll have to pay for that. You just go on to the ACT website and set up an account and all that kind of good stuff. They only take the highest one, Kenzie. They'll never see that you took it multiple times. You can only report your highest one. Yeah, it does cost money, but So very few people I know of do just tremendously well by taking it once. Most people take it more than once. I can tell you my own kids took it at least 4 times. So, but thank y'all so much. If you run across any other ACT practice problems, there's all kinds of stuff on the internet. If you run across a problem and you don't know how to work it and you're just studying before next week, just send me a snip of it and I'll be glad to make a video for you and work it out. And I appreciate y'all coming, and good luck, and get some rest. Get some really good rest the night before. We already talked about bringing a snack. You will be able to leave the room. You probably need something to drink and something to eat, and to charge up that brain again so you can finish the second half of the test. But y'all have a great day. Any last minute questions? We do have honors algebra 2 tomorrow at 11:15. Oh yeah, we still have it. Bye, Amber. You're welcome. Bye, guys. Bye, Kenzie. Bye, everybody.